I've never done it, and I still do help.
Okay, we are starting back into lesson 9.4, where we left off on Friday. Okay, if you remember on Friday, we started talking about arithmetic series. And when we talk about arithmetic series, first of all, let's review. What do you remember about an arithmetic sequence? What's it mean to be arithmetic? Yeah, you add the same number over and over to get to the next term, right? That's an arithmetic sequence. So when we were talking about arithmetic series on Friday, the difference between a sequence and a series is that we're adding all the terms together. So we were looking at these arithmetic series and specifically how to find the sum of an arithmetic series. Okay, that was our big task on Friday, was figuring out how to use this formula and find the sum of an arithmetic series. Now, today, we are starting into using something called summation notation. So we're still finding sums of arithmetic series. We're still going to use that formula I just talked about. But we're going to talk about summation notation. So this right here, and so what this is this stands for the sum of a group of numbers. So in other words, a group of numbers added together. And when we look at this E here, there's always going to be a number below it and above it. The number below it is the number you start with. So in this case, like n equals 3, like the number you start with, that you're plugging into the formula. The number on top, okay, is going to be the number you end with. So like the very last number that you plug in. And then over to the right is where you will find your formula. Okay, now, the number on the bottom, which is the first number you're plugging in, it will sometimes be referred to as the lower limit, because it's the lower limit of numbers you're plugging into. The number on top will sometimes be referred to as the upper limit, because it is the last number you're going to plug in. Now, to kind of mimic it or to show you, with this formula right here, or this, series, 9 plus 16 plus 25, plus 108 squared. Well, what do you recognize about 9? 9 is what? 3 squared. 16 is 4 squared. 25 is 5 squared. So on and so forth, all the way up to 108 squared. And the idea here, if you will, notice, that's what this summation notation represents. The sum from n equals 3, because what's the first number plugged in over here? 3, to, what's the last number plugged in? 108. And what did they do every time they plugged in a number? They were squaring it. And so the formula says n squared. So you take the number 3, plug it into that formula. Plus, take the number 4, plug it into the formula. Plus 5 squared, plus 6 squared, plus 7 squared, plus 8 squared, plus 9 squared, plus 10 squared, all the way up to 108 squared. Okay, and so this summation means finding the sum or adding all those terms up. This is just a kind of condensed way to show it. So summation notation. Now, we'll be working with it plenty, so hopefully you'll get an idea of how to understand this. No question yet? Okay. Very possibly. If I don't get your question answered, come back to it, okay? Aha, there. Can't find where I'm out of my paper here. Okay, so on the back, the first thing we're going to practice is writing summation notation. In a little bit, we'll go the opposite. But right now, we're going to write summation notation. So, what is the summation notation for 7 plus 11 plus 15, so on and so forth, up to 203 plus 207? So let's start with, what can you identify? What can you notice about this series? Okay, adding 4. 7 plus 4 is 11. 11 plus 4 is 15. 203 plus 4 is 207?
So,
What? No. Nope. Give me time. Okay. What do you know about this 4? Go back a couple of lessons. What is 4 called? The D. Remember, it's the common difference, the number you're adding repeatedly. So one thing I'm going to want to note is that D is 4. What else do we usually identify besides D? A1. What is A1? A7, because the first term is 7, correct? Now, okay, there's a couple of things we need to find, and I'll kind of show you a process. But one of the hardest things here is finding the formula. Because you've got to have a formula for 7 plus 11 plus 15 where, you plug in numbers and it gives you out these other numbers. Now, back in lesson 9.1, it was a struggle to find formulas, wasn't it? Because I didn't really give you, it was just kind of coming up with them on your own. But 9.2, we were given formulas for sequences like this, yes? What kind of formula would be helpful to use here? Explicit? Yeah. We were given an explicit formula for an arithmetic series, yes? Or arithmetic sequence. You might have to go back 2 lessons to get to it. But what is our explicit form for an arithmetic sequence? A of n equals A of 1 plus n minus 1 times d. I'm not saying you have it memorized, but does it seem familiar to you? Because I'm not asking that you have it memorized, but you should have used this enough by now that, like, oh yeah, I've used that. Okay, do you remember how to fill it in? Can we fill in A1 and D here? So A of n equals A1, which is 7, plus n minus 1 times d, which is 4. What? Distribute. So we're going to take that 4 and distribute. And so when we distribute, still going to be 7 plus 4 times n is 4n minus 4 times 1 is 4. I would encourage one more cleanup, and that is the fact that 7 and 4 can be subtracted. 7 minus 4 is 3, so I can write this formula as 4n plus 3. Okay, guys, that is the formula you're going to use. When we set up our summation notation at the end, that's the formula you're going to use. So good news, you can use that explicit formula to find the formula that we need here. Now, think about it. Besides the formula, we also need the lower limit and the upper limit. So the idea is the lower limit, the number that I plug in this formula to get 7, which, I'll be honest, should be pretty obvious. Now, if you're sitting here saying, I don't understand what you're saying, okay. I want to take this formula, 4n plus 3, and I want to know what do I have to plug in to get the first term. That's what I'm looking at. Okay, so using the given formula, I need the number that's going to give me the first term, which I agree with 1. If you're sitting here saying, yeah, that's not obvious to me, didn't we just set up an equation we can solve? I have confidence you guys can all solve this equation. That's not an issue. Subtract 3 over. 7 minus 3 is 4. 4n equals 4. divide by 4, and n is 1. Okay? I'm not saying you have to do all that work out. I'm just showing it for the sake of the notes. But n equals 1 is going to be the lower limit, because that's the first number I plug in to get the first term. Now, we have a formula, we have a lower limit. That means we're also missing the upper limit. Now, can you figure out how to do the upper limit? Huh? The last term, right? So, what number do I plug into this formula to get my last term? So in this case, to get 207. Now, officially, what's that mean I can do? Take the formula of 4n plus 3 and set it equal to 207. So in other words, you always set in your equation the formula equal to the first term, formula equal to the last term. So if it's 4n plus 3, I'm going to subtract 3. 207 minus 3 is 204. If it's 4n, I'm going to divide by 4. 204 divided by 4 is 51. 51 is what I'm going to call my upper limit. So, over to the right, I'm going to write my summation notation out. So, first of all, it's that sigma, a big fancy E, however you write it. The lower limit is the number you plug in to find the first term. So we're going to put that down below, and that's n equals 1. The upper limit goes up top, and that's the last number you use, which we don't need to put n equals. We can just put 51. And then the formula that we created and used goes off to the right, and that is 4n plus 3. You will notice officially I put the formula in parentheses, just because indicating the entire formula goes with the summation notation. Yes? Not traditionally. Okay? So this says the sum from n equals 1 to 51 of 4n plus 3. So that means I plug in 1, then I'm going to plug in 2, then I'm going to plug in 3, plug in 4, and then I'm going to add all 51 of those terms together once I get done. So I'm going to plug in all those numbers up to 51, and then this right here says summation. So that means I would be adding all 51 terms together if we were actually finding a sum right now. Okay? Questions on how I found all that information? And some of it you can maybe shortcut. Maybe the formula was more obvious to you. Okay? I will tell you the way we're doing this, n will usually be 1. Okay, just based on because we're using our explicit formula over here, n will usually be 1. It'll just be a matter of finding the upper limit. When we're finding, it'll usually be 1. The lower limit doesn't have to be 1, but as we're finding them based on the methods I teach, that's what it'll usually be, and based on the examples we have. Okay, should we try B? See if you can follow that same process we just did. Okay, -5 plus 2 plus 9 plus 16 up to 261 plus 268. Okay, thoughts? Okay, identify what's going on here, right? -5 to 2. -5 plus 7 is 2. 2 plus 7 is 9. 9 plus 7 is 16. And 261 plus 7 is 268. All in agreement, right? Okay. So what is that 7 called? That is D. That is our difference. What else do you need to know besides D? A1. What is our first term? -5. What do I do with that D and that A1? Okay. We want to find our explicit form. A of n equals A of 1 plus n minus 1 times D. Okay. A of n equals negative 5 plus n minus 1 times 7. You know you need to distribute. Negative 5 plus 7 times n is 7n. Minus 7 times 1 is 7. What does this look like cleaned up? Seven n minus 12, because negative 5 minus 7 is minus 12. That is your formula for your summation notation. Now what do I need to do? What? Okay. Find n, find our lower limit and our upper limit. The lower limit should usually be, I hate to use the word obvious because some of you are going to say, yeah, it's not obvious at all to me. But it's, easier to find. Take your formula and do what? Set it equal to the first term officially. And again, if you're skipping that step, always at least mentally check before you just totally skip that step. So if it's 7n minus 12, I'm going to add 12. Negative 5 plus 12 is 7. 7n, divide by 7, and n is 1. Kind of what you expected? That is your lower limit. Again, I'm not concerned whether you guys can find the lower limit. How do I find the upper limit? Okay, your equation equal to the last term, the highest term. So if it's 7n minus 12, we're going to add 12. 268 plus 12, 280. Divide by 7, and n is 40. That is your upper limit. Okay, did you write in your summation notation? N equals 1 on bottom. I'll give you that one. What goes on top? My upper limit of 40. And what else do I need? The formula of 7n minus 12. So that means I'm going to plug in 1 through 40 into that formula and add all those pieces up. Okay. Give C a try if you haven't already. My concerns are you finding the formula and finding the upper limit. Because if nothing else, you're just going to get to the point by habit you put the lower limit as 1. Which you shouldn't totally just think of it as a habit, but. Okay, 500, 490, 480. So on and so forth down to 20 and 10. What do you notice? Okay. Adding negative 10. If your brain says subtracting 10, that works too. So what is that negative 10? That is your common difference, your D. And what else do I need to know? A1, my first term is 500. Okay. Explicit form. I don't know why, but I keep writing out the basics. A of n equals A of 1 plus n minus 1 times D. A of n equals A of 1, which is 500 plus n minus 1 times negative 10. What do you need to do next? Distribute the negative 10. So 500 negative 10 times n is minus 10n. Minus negative 10 times minus 1 is plus 10. Cleaned it up. I see a negative 10n. And then 500 plus 10 is 510. Okay. Lower limit. I'm going to take my equation. Negative 10n plus 510. Now, the other one's not so easy to eyeball, is it? Negative 10n plus 510, and this time we're saying equal to 10. So subtract 500. 10 minus 510 is negative 500. Negative 500 divided by negative 10 is positive 50. Okay. What can you tell me? N equals 1 to 50 of negative 10n plus 510. All this process, learn this process, memorize this process, and it's not hard to write the summation notation. Okay. Now, the other part of today's lesson, we essentially have to reverse what we're doing. We're going to reverse, and they're going to give us summation notation. And it's not that we're finding the series, it's that we're finding the sum. Now, do understand there are limitations with the computer, and so it's depending on the computer, the program. N equals 1 and the 70 are what should be below and above. Yes? Understand that those are the lower and upper limits. So this is the summation from n equals 1 to 70 of 5n plus 3. Our question is, what is the sum of the series? What? Yep, we have to find what all the numbers in this series add up to be. Well, okay, so if we have to do this one by hand, how many terms are there going to be that I have to add? We're going to plug in 1 through 70 into this formula, and there'd be 70 terms if we have to add this by hand. Okay? Now, are you expecting that I'm going to say let's add 70 terms?
No.
Probably not. Now, okay, here's going to be the big deal today. You need to look at the formula and decide, does this formula represent an arithmetic sequence? Because if it does, we have a shortcut. If it doesn't, we're adding them all by hand. That's what it comes down to today. Now, think about the 3 formulas we just wrote. Does this 5n plus 3 resemble the 3 formulas we just wrote? Is it in a similar format? Yeah. And here's what you need to notice. If this is what I would call linear formula, when I think linear, I'm thinking like mx plus b. If this is in a like y equals mx plus b form, that means it's linear. And if it's linear, guess what? We can use our arithmetic formula to find the sum. So 5n plus 3, linear? Yeah, that'd be like 5x plus 3. So because this is linear, I know that this is an arithmetic series. Because it's an arithmetic series, we learned a formula on Friday that could help us. Do you remember our summation formula on Friday? We learned how to find the sum of n terms. S of n equals n over 2 times a1 plus a of n. Yeah, we can use that formula. Now, I'm not going to write that formula down quite yet. Let's find a couple of pieces of information. How do we find the first term in the series? Plug the lower limit into your formula. So if I plug 1 in for n, 5 times 1 plus 3 is 8. So that 8 is our first term in the series. So it's going to be 8 plus something, plus something, plus something, plus something. We need to know the first term. What else do we need to know? The last term. Nope, we don't have to find them all. Because this is arithmetic, we don't have to find all of the pieces because we're going to use our formula here when we get done. Now, we have to know the first term, the last term. How do I find the last term? We're going to plug in our upper limit, which is 70. So we're finding a of 70. So 5 times 70 plus 3. 5 times 70 is 350, plus 3 is 353. So we just found our first and last terms by plugging in the lower and upper limits. Now, the formula that I'm trying to get you guys to remember from Friday. S of n equals n over 2 times a of 1 plus a of n. It's on the front side of your notes. Probably boxed if you do everything I do. Because I boxed it. This S of n allows me to find the sum of the first n terms in an arithmetic sequence. This is linear. We decided it's arithmetic, so we can use this formula. So, S of n. How many terms are there? 1 to 70 is 70 terms, yes? So we're going to say S of 70 equals n divided by 2. So 70 divided by 2 times a1 plus a of n, which a1 is 8 plus a of n is 353. 70 divided by 2 is 35. 8 plus 353 is 361. 35 times 361, my mental math ends here. 12,630. Those of you that want to give it good old try and add them all by hand, more power to you. I personally will be using the formulas. Okay, B. I got about 10 minutes. I got about 3 more examples I want to get in here. We'll see if it happens. Okay, so B. The sum from n equals 1 to 7 of n minus 1 quantity squared. First of all, we've got to decide, is this an arithmetic sequence? Which means I want to know, is this a linear formula? What's my formula? N minus 1 squared. Is that linear? No, that's not linear. So, because this is not linear, that means this is not arithmetic. We could not add the same term over and over. If this is not a linear formula, then it's not an arithmetic series. Which means, in order to find the sum, you're doing it by hand. Now, good news, there's 7 terms as opposed to 70 terms. That makes a big difference, doesn't it? 7 terms. Is that reasonable to do by hand? Definitely. So, let's start by finding a of 1. In order to find a of 1, plug in 1. 1 minus 1 squared. 0 squared, which was 0. Well, that term's going to be easy to add. A of 2. 2 minus 1, quantity squared. So 1 squared, which is 1. A of 3. 3 minus 1 squared. 2 squared, which is 4. A of 4. 4 minus 1 squared, which is 3 squared, which is 9. A of 5. 5 minus 1 squared, so 4 squared, which is 16. A of 6. 6 minus 1 squared, which is 5 squared, which is 25. A of 7. 7 minus 1 squared. 6 squared, which is 36. What do I have to do now? Add them by hand, yes, or by calculator? I don't have a shortcut here, guys. So what is 0 plus 1 plus 4 plus 9 plus 16 plus 25 plus 36? Okay, so if you get one that's not arithmetic, because it's not a linear equation, you're doing it by hand.
I'm assuming that they're just going to be as
Now, I'd like to get C and E in real quick. I don't know if this is possible to get both of these in or not, because E is kind of a cool problem. So, okay, C. What do you notice? Linear, not linear. Arithmetic, not arithmetic. 3n minus 8? Is that like slope-intercept form? Yeah. So guess what? This is linear, which means if it's linear, it is arithmetic. Which means the good news is I don't have to find 40 terms and add them by hand. I can find the first and the last and use the formula. So, first term. What's my first term? Three times 1 minus 8, which is -5. I plugged in 1 to my formula to find the first term. How do I find the last term? Plug in my upper limit. So we're going to find A of 40. 3 times 40 minus 8. 120 minus 8, which is 112. And now we use the summation formula. S of n equals n over 2 times a of 1 plus a of n. Okay. S of, what is n? How many terms are there? 40, because it's 1 to 40. So 40 divided by 2 times negative 5 plus 112. Forty divided by 2 is 20. Negative 5 plus 112, 2,140. Okay. Now, I want to do E. Okay, so some things to notice about E. First of all, it does start at 0, yes? Which technically, think this through to me. If 1 to 100 is 100 terms, what about 0 to 100? 101 terms? Okay, so there's 101 terms to add. Now, is this linear? No. If you got a power in there, it's not linear. Is this arithmetic? No. This is not arithmetic. Guess what we're doing with those 101 terms? We're adding them by hand. Let's go. Okay, let's find them. Okay, so the first number we're going to plug in to find the first term is 0. Negative 1 to the 0. Anything raised to the 0 is 1.
Ah, I said 1 first and you shook your head, so I was confused.
I heard too many zeros. Okay? Negative 1 to the first. When you raise a number to the first, it's always itself. So negative 1 to the first is negative 1. Negative 1 to the second. What happens when you square a negative? Becomes a positive. And when any 1 to any power is 1, yes? Okay? Negative 1 to the third. What happens when you have an odd number of negatives?
Oh,
Negative 1.
pattern.
Oh my goodness.
I see. Okay.
Negative 1 to the fourth. Positive 1. Negative 1 to the fifth.
I wonder
Negative 1.
the problem.
Negative 1 to the sixth. Positive 1. Now, obviously that's all I have room for. We have a whole bunch more to go, but are you noticing something?
A pattern.
Okay. Remember, we are adding these, yes? What is negative 1 plus 1? 0. Negative 1 plus 1? 0. Negative 1 plus 1? 0. So realize, here's the deal, guys. The way I have it written, the first and second cancel out. The third and fourth cancel out. The fifth and sixth cancel out. That's going to work all the way up through 100. What about this guy? My answer is 1, because everybody else is going to cancel out. Now, if this was just 1 to 100, you'd have 50 pairs canceling out. So it would be 0. But because we had 101 terms, we had 1 extra 1 left over. So, there are some creative things you can do. We did not have to add 101 terms by hand, but we did add 101 terms.
I knew there was, when you said, well, we're doing it by hand, I was like, no, we're not.
We did do it by hand, though.
we need 6
Okay.
terms.
For tomorrow, you need to finish lesson 9.4 in Math Excel. And D would be another one you'd be doing by hand, but there's only 4 terms. F, you could use the formula. Okay, finish lesson 9.4 for tomorrow. Bring your questions. I do expect to probably see some questions tomorrow.
As long as I can find it.
equation.